let us have a quick look at what we have already spoken about. Okay, so on Monday's lesson, what we had a look at was our very, very first geometric reason. Now, guys, remember what we're doing at the moment. Our current course is geometry. So what we're currently doing at the moment is we are looking at relationships between straight lines and angles in order to go and determine missing angle sizes. Now, I said to you on Monday that we are going to have a look at a lot of different reasons that you're going to have to be able to apply. We've only had a look at one so far. If you've done geometry already at school, you probably know all of the geometric reasons for grade 8, and that's absolutely fine. But just bear in mind that we have currently only looked at one reason, and that is the reason that angles around a central point must add up to 360. Now, guys, I don't know if you remember, I said as well on Monday that what I really advise you do is you have like a separate piece of paper as we work through this. And every time we learn a new reason, you write that reason down on your piece of paper. And what it will become is sort of like your cheat sheet for geometry. It means that whenever you are answering a geometry question, past paper, anything like that, you've got your cheat sheet there next to you, and you can always refer back to see what reasons you should be using. Whoops. Sorry. Okay, so if we just recap the one reason that we have done together so far, we have said that angles around a point add up to 360 degrees. I'm very sorry if you can hear my cat moaning in the background. He's having an existential crisis. Angles around a point add up to 360 degrees. So guys, basically what that means is if we look at this diagram, here is my central point. If we add all of the angles up around that point, every single one, we will get 360 degrees. Now, there are definitely different reasons that we can give for this question. But again, we have only learned one together. And so I'm going to use that one reason that we've learned. You can, like I say, if you've learned different reasons, you can use different reasons. And so in geometry, what sometimes happens is that you get the correct answer, but your reason is different. That is fine. It is fine to have a different reason. Sometimes we can apply more than one reason to a question. But like I say, right now, we have only done angles around a point. That's the reason I'm going to use. Okay, next thing is, please remember that what I said in our very first lesson was the fact that having a statement as well as a reason is incredibly important in geometry. So what I suggest is you try and separate your page. So when I say separate your page, split it in half for yourself. One half will be the statement that you're going to make. The other half, your reason. Okay, and all this does is it reminds you that you have to make a statement, but also give a reason. And we spoke about the fact that if you don't give reasons, you can lose 50% of the marks just because you haven't given a reason. Okay, so if we have a look here, our statement is going to be that we know that x plus 45 plus 135 plus 45. So if I'm adding all of these four angles together, must give me 360 degrees. And the reason I am making that statement, and remember, we can abbreviate and use symbols in our reasons. The reason I'm giving here is angles around a point. So that slanted L means angles, PT means point. Right, so quickly in the chat, what I want you guys to do is work out the value of x for me. So tell me what x is for this question and put your answers in the chat for me. Awesome, grade 8, well done. Okay, excellent, well done. So guys, there's lots of different ways that you can go about sort of now solving for x. Remember, this is like an equation. And so if you choose to now, or not if you choose, you should now be applying your equation solving knowledge. So how to solve an equation, we should be applying that. Okay, firstly, the 45, the 135, and the 45 are all like terms. So let's just add them together. It's going to make life so much easier for myself. So that takes me up to a sum of 225, which we know that when we add to x must give us 360. Exactly as has been put on the chat there, we now use our inverse operations and we subtract 225 on both sides, because that will allow us to solve for x. And so x, exactly as all of you have said, is 135 degrees. All right, so that is the first reason that we've had a look at angles around a point. Nothing too complicated. What's really important to remember though is if you make a statement, you have to give a reason. All right, so guys, just take a screenshot of that. We aren't going to do any questions. Reason being is because I've done a whole lesson on this. So those people asking where should I go and get the recap, the lesson that we have already done, as well as all of the other videos, as I've said, is on Watobe's website, or you can find it on YouTube. That is where you will find previous lessons. So go and have a look there. All right, but let us get on to what we're going to have a look at today. Sorry. So we're going to have a look at two reasons today. And the reason for that is because the second reason of complementary angles doesn't actually come up a lot, but it is important to know. So we're going to do two in one lesson today, whereas we usually do only one reason per lesson. Well, today we're going to have a look at two because the second one honestly doesn't come up a lot, but it is an important terminology to know and application to know. All right, so our very first reason that we're going to look at today is a reason dealing with angles on a straight line. Okay, so again, those of you that have already done this at school, you'll know about this. But basically what this says is that adjacent, now adjacent means next to, so angles next to each other on a straight line add up to 180 degrees. We could also call this, or we could also say they are supplementary. So supplementary means that the angles add up to 180. Guys, questions in the chat, we only raise our hands when I ask. All right, now the first part of that statement, the adjacent angles, that is really important. If your angles are not right next to each other, basically what that means is they must share a common vertex, as Atlachang has put on the chat there. If they aren't sharing a common vertex, we have got, or we don't have rather, adjacent angles. So if we look at our diagram, we can very clearly see that we have an angle here at ACD, as well as an angle created at BCD. Okay, so we've got two angles here. Now, very importantly, hopefully what we notice is that they both share this vertex at C. And because of that fact, they are right next to each other. This angle ADC is adjacent to or next to angle BCD. We can also very importantly see that these angles are on a straight line. Okay, so they both sit on the line AB or ACB, either way, it doesn't really matter, but they are on that straight line. So guys, excuse me, if we go back to the first reason that we learned, the first reason that we learned was the fact that angles around a point, so if this is my central point, all of the angles created around this point, they add up to 360 degrees. And that's because a circle has 360 degrees in it. If we think about a half circle, okay, so if I cut the circle in half, we know that one half of a circle contains 180 degrees. This is also a straight line. And so angles on a straight line add up to 180 degrees. And this is why we have the statement on the side here that angle ACD, the one I drew in green, plus the angle DCB or BCD, doesn't matter, the one I drew in pink, they must add up to 180 degrees. Now again, in geometry, whenever we make a statement, we have to give a reason, and I've told you this already. The reasons I'm putting in these little blocks on the side. Our reason that we would use for this statement is angles on a straight line. Now again, guys, someone said I was cutting up, so I'm just going to turn off my camera. Hopefully that helps. Remember, guys, that sideways L means angles. STR means straight. We're just abbreviating it. Remember, mathematicians are quite lazy, so there's often abbreviations that we use. So angles on a straight line. Again, angles next to each other or adjacent angles on a straight line must add up to 180 degrees. Okay, so that's our second geometric reason that we are learning and that we are eventually going to apply today in our examples. Right, I'm just going to stop there because that's been a lot of information. If anyone has any questions that they would like to ask, now and only now is the time where you can raise your hand and ask me whatever question you have. If you don't have questions, that's fine. We'll have a look at our next reasons. But like I said, this has been a lot of information. So if you've got questions, let me know. Right, Lindor? There should be a pop-up to unmute.
I'm sorry, ma'am, I'm still looking for my book, which I was confused at school.
Okay, so I'm not answering any other questions other than what we've spoken about here, hey?
Yes, it has to do with something that was spoken about.
Okay, Lindo, that's still okay. Just find your book, and we're just gonna take Specifi's question for now, okay, while you're busy preparing. Specific, your turn. Guys, remember also to put your questions on the chat. I'm here also.
Okay, Mas. So my teacher, my math teacher is here. She doesn't like teach a lot of stuff to like children. So like I'm failing her math like terribly because like everyone doesn't even understand her math. So I came to. So
okay, well, we're really glad to have you here. So hopefully this will help. But what is your question that you have about what I've gone through?
So like we learned adjacents last term, and
yeah,
I didn't really understand it because she just gave us words to like write.
Okay, so remember adjacent, all adjacent means is next to. So as long as they sit next to each other, we can say that they are adjacent.
Yeah, now I know that.
Okay, good, awesome. Do you have any other questions?
No, I'm good.
Awesome. Okay, so Botale?
Hi, ma'am.
Hi.
I wanted to ask that, ma'am, if it would be a Z, would it still stay adjacent or the?
Okay, so I think what you're talking about involves parallel lines. We haven't gotten there yet, so just wait until we get there. But no, they're not next to each other. Yeah.
Ma'am, like I'm asking, ma'am, if it were to be like a letter Z, ma'am, would it still be adjacent or not?
Are you asking me that if you had a shape like this, would those two angles be adjacent?
Yes.
All right, so as I've said, what you are talking about is parallel lines. We are not doing that right now. We will get there, but we're not doing that right now. But no, they're not adjacent. They're not next to each other.
Okay, ma'am.
Yeah. Apulele?
Ma'am, may I please ask, will there only be like A, C, D, or can the teachers actually like put numbers?
No, we'll put numbers. So we're going to do a few examples now where there's numbers and we're going to solve for unknowns. But sometimes then your English, but sometimes there will be angles with no numbers, and then we would just have to use the label like you've just said.
Okay, ma'am. Thank you.
Sure. I think it was Lindor. Do you have your book now? Do you have your question? Guys, please remember to mute yourselves once you are done with your question. There we go. Okay, Lindor.
Hi, ma'am. In school, we were given a question with which was a straight line. It had two y's as well as two numbers. So I was confused that how do I calculate it?
Okay, I'd have to see the question. But if there's two y's, then remember what you're doing is you're saying y plus y and then plus the two numbers. And as long as they're all on a straight line, then that would mean that it must add up to 180.
Thank you, ma'am.
Okay. All right, so yes, that's the first reason that we're going to have a look at today. The second one that we're going to have a look at today, like I say, does not come up a lot. So please don't feel stressed if you haven't done this at school. It is one that we do need to be able to apply, but it's not one that we use a lot. And that reason is, sorry, I just had an absolute brain fart. That reason is complementary angles. Now, what you guys have probably heard of is the complement of or complementary angles, but what we often don't realize is that it is actually a geometric reason we can use. So we've just spoken about angles on a straight line. Complementary angles are angles that add up to 90 degrees. So very importantly, if you've got two angles, if you look at our diagram here, we've got the two angles 40 and 50. If we were to add them together, we are going to get a sum of 90 degrees. And whenever these adjacent angles add up to 90 degrees, we have got complementary angles. Exactly, guys, like a right angle. So if we wanted to, we could put that square here, indicating that it is a right angle. All right, so I'm just going to write that out for you. Adjacent angles, so angles next to each other, add up to 90 degrees. Okay, so we've got so far the reason the reason that speaks about the fact that angles around a point add up to 360. We've now halved that circle and we've gone to a straight line. We've got angles on a straight line add up to 180. And then we've gone a step further that says angles that add up to 90 degrees and that are next to each other are complementary angles. Now, again, if we make a statement that they add up to 90, we have to give a reason, and our reason is comp angles, complementary angles. Right, so I'm going to give you a second to screenshot those two reasons, and then what we're going to have a look at is we're going to have a look at some examples applying both of these examples. Please remember in the chats, appropriateness and relevance. If you're not going to do that, I will just remove with not so much as a goodbye. Okay. Right, guys. So let's have a look at some examples here. If we have a look at our first example, and please only just focus on the first example to start off with, that's the one that we want to have a look at here. We've got a diagram where we've got an angle of 50 and an angle of X. And obviously, remember, like I've said to you, the question would say something like, determine the value of X. Sorry, I'm shushing my cat. He's being very dramatic. Right, so determine the value for X. Now, guys, as we start to learn more and more reasons, we're going to have to start to look out for certain things in our diagrams, like, is there a circle that I could create? Is there a straight line in my diagram? As we start to learn some other reasons, is there a cross shape? Is there, like was mentioned earlier, Z shape? So we're going to have to start being quite mindful of what to look out for in our diagrams. Now, in this very first diagram, what we see is that both 50 and X fall on the straight line at the bottom here. The second thing that we see is that they are right next to each other. They are adjacent angles. And so hopefully what that takes us back to is angles on a straight line. If I add the two angles together, I must get 180 degrees. It's forming that half circle, that 180 degrees. Now remember, guys, anytime you're doing geometry, you have to give a statement and you have to give a reason. So we split our page up in half so that we remember to do that. And yes, you do have to give a reason. There was a question on Monday, do we have to give reasons? Yes, you do. You have no choice, unfortunately. So our statement here is the fact that we know that if we take X plus 50 degrees, we have to get 180. I've made the statement of what has to happen, but the reason for that, remember, is angles on a straight line. We can use the symbol for angle, so that's sideways L. We can abbreviate straight to STR. Some people, I think, learn adjacent angles on a straight line or angles on a straight line supplementary. All of those are absolutely fine. Remember, I've said to you that some of the reasons look a bit different, but as long as it is a reason that either me or your teacher has taught to you, you are welcome to use it. Right, once we've made our statement, we obviously need to go and answer the question, which is solving for X. And this is where our inverse operations come in. So we are going to subtract 50 on both sides of my equation to get X alone. And so we get that X is equal to 130 degrees. Remember, you can always check this by substituting back and making sure that your equation is true, just like we do in solving equations. All right, and guys, that's essentially angles on a straight line. Obviously, as our diagrams and our images and our questions become a little bit more complicated, we need to think a little harder. But in its essence, that is angles on a straight line. So what I'd like you guys to try for me is I would like you to try question 2. So all by yourselves, I want you to have a go at answering question 2 here. Please remember you need to give your statement and your reason. So remember to set up your page appropriately. Split it in half for yourself. Make your statement. Give your reason. And then on the chat, what I want from you is I want your answer as well as your reason. Okay, so I want the answer and your reason that you use. Amanga Sisi, it is not always the reason. It is the reason if we are going to say that angles added together must give us 180 because they're on a straight line. So what's really important is that we pick the reason based on the appropriate information that we're using from our diagram. Right, so guys, remember as you're solving inverse operations, all of those things that we learned from equations. And remember, like I say, to give a reason. No reason, no marks. Good, guys. All right, would anyone like to raise their hand to give us the answer as well as the reason for this question? Tanyane?
Hello, ma'am.
Hi.
So the answer is 40 degrees.
Perfect.
And the reason is because of angles on a straight line.
Excellent. Well done. Okay, so guys, my working out is a bit separated here because I actually obviously want to do the whole thing. But exactly as Sinanya said, our answer is 40 and our reason is angles on a straight line. So our statement would be that x plus 60 plus 80 must give us 180 degrees. If you don't realize what's happening right now, guys, I'm explaining this question, so you need to focus and listen. And so what we now need to do is we need to go and we need to solve the equation. Now 60 plus 80 is 140. So we've got x plus 140 is 180. And using our inverse operations, we are going to subtract 140 on both sides. 180 minus 140 gives us that answer of 40 that Sanyanya said. So guys, here, because we had the straight line, frankly, I can't highlight in a straight line though, so that's fine. Because we had the straight line, because all of the angles that we were given, the 60, the x, and the 180, were adjacent angles on that straight line, I could add them all together in order to get 180 degrees, and I could therefore go and solve for x. Alrighty. I'm going to give you one more and then we'll take a little break because you guys are doing really nicely today and I really appreciate how well we're behaving. So I want you guys to try question 3 for me. Again, same as before. Answer as well as reason on the chat for me. Remember, guys, set up your work if you want to. Split your page in half. You've got a statement. You've got a reason. I want both. And then, like I say, in the chat, I want the answer as well as the reason. This one is a little harder, but you definitely can do it. Just think very carefully about what you're doing. And obviously, guys, when we go through it, make sure that if you need to make any corrections, you do that. Remember, guys, if you want to check, substitute the value of x that you get back into the diagram or back into your original statement and make sure that it does actually mean that your statement is true. Remember those reasons, please. Okay, guys, just another important thing, just because I see that someone's put there on the chat x1 and x2. Remember, if you've got the same variable but in different angles or at different angles, it does actually represent the same value. As long as the variable is the same, it will be the same value. Okay, looks like we're getting there. Well done, guys. Right, so our statement is, if we look at our diagram, we've got a straight line. We have got two adjacent angles on the straight line that when we add together must give me 180 degrees. So our statement is that x plus 60 will add up to 180 degrees. My reason, angles on a straight line. All right, now we've got an equation we need to solve. X plus x, those are like terms. So x plus x is 2x plus 60 equals 180. And like I've been saying, guys, this is solving an equation. So we're going to subtract 60 on both sides. Just do this because I'm not going to have enough space otherwise. Subtract 60 on both sides. So I've got 180 minus 60, which we know gives us 120. And then to solve this equation, I need to divide both sides by 2 to get rid of that coefficient. And so x is equal to 120 divided by 2, which is 60. All right, so that one was definitely a little trickier, but you guys dealt with it so nicely. So you must give yourselves a pat on the back there. I'm sure there was a sentence in my head that's now flown away. What we need to remember is statement, reason. As long as we set up that initial equation with care and consideration, we will be able to get our answer. All right, so what I'm going to do is, just in case you didn't get screenshots of all 3 of them, I'm just going to do that. Please take your screenshots of those 3 questions. We'll have a little stretch break, a little brain break, and then we'll have a look at a couple more before we end off. Okay, so guys, I think just based on time, we won't do like a proper brain break, but please do just take like a quick 2-minute break, get up, stretch, move, and then we'll carry on. Now, your working out doesn't have to be identical to mine. Like we know that working out doesn't have to look exactly the same. As long as you're getting the correct answer, you're applying or you're doing your maths correctly, and you're giving your reason, it's okay. So guys, while everyone's taking a stretch, having a bit of a break here, if anyone has any questions, you may raise your hand to ask me. Otherwise, like I say, in a minute or so, we're going to have a look at a few more. Elihle? You need to unmute yourself. There should be a pop-up to unmute. Elihle, there's a pop-up that you need to push to unmute yourself. Okay, you might have a bit of an audio thing. You need to double check your audio connection. I'll come back to you in a second, see if you can figure out where the problem is. Thandawake?
Okay, ma'am. Also, this is how did you get to 60 degrees? Because I'm just 120.
Okay, so remember for this last one, there's 2 x's there. I'm solving for just 1 x. So that's why in my equation, let's get a highlighter here. So that's why in my equation, I've got 2x because I've got an x here and an x here. If we go back up to the question, it said determine the value of x. So I need to solve for 1x only, which means that once I've got 2x equals 120, I still need to divide both sides by 2 in order to get x alone. So 1x is equal to 60. And if we go back and we sub that in, this would be 60 and 60 plus 60, which is in total 120. And so 120 plus 60 does give me 180 degrees. I hope that made sense, Thandawake. If not, make sure you pop it on the chat, but hopefully that makes sense. Kesha?
Ma'am,
Yes.
I still don't understand. Why do we only solve 1x instead of both?
Because the question asked us to solve for x. And whenever you solve an equation, you're always solving for 1x. Remember, like I said, the x's are the same value. So once you know what 1x is, you know what both x's are anyways.
Oh, okay, ma'am.
Okay, so guys, that's really important. Because they're both x variables, once you know what one is, you know what every x variable in the question is. So if there had been a third x on this diagram, it would also be 60. Once you know what one is, you know what all of the x's are. Okay, Bokang?
Ma'am,
Yes.
I wanted to ask if, let's say, instead of 2x's, it was x cubed, would it still be the same, ma'am?
X cubed, so x to the power of 3.
Yes, ma'am.
Yup. I'm going to be honest, Bokang, I have never seen a question where they have used an exponent for x. However, if for whatever reason we did, you would still have to apply inverse operations. So the inverse of cubing something would then, you would then have to cube root.
Oh, okay, ma'am.
Okay. But I've never actually seen that asked that way. I'm not saying they couldn't, but I've never seen it asked that way. But then inverse operation applies. Ribabale, I hope I'm saying your name correctly. Please correct me if I'm wrong. There should be a pop-up to unmute.
Hi, ma'am.
Hi.
How are you, ma'am?
I'm fine. How are you?
I'm good. I wanted to ask that is it possible that the question can ask us x to xy in the question? Is it possible?
It is, so we can involve y, but then what will generally happen is that we'll have enough information in the rest of our diagram to solve for x, and then maybe that will help us to get y. At this point in grade 8, we'll never ask you to solve for x and y at the same time. There'll be sort of like solve for x, and then in the next question, solve for y, and you'll be able to use what you got for x to help you get y.
Yes, ma'am. Thank you, ma'am.
Sure. Okay, Leafly, let's try this again. Still nothing. Okay, Leafly, try and put your question on the chat, my sweet, because I don't know what's happening. I don't know why. Don't know why you can't unmute. Yolanda, I don't know if you have any solutions to the problem here, but I honestly don't know.
No, I'm also not sure what's, yeah.
Try put your question on the chat and then we'll help you there. Right, last one, Apelele.
Ma'am, may I please ask, can they like mix the angles?
What do you mean?
Like, let's say they put angles on a straight line together with complementary angles.
Oh, yes, definitely. So you're going to see that as we start to sort of level up our questions, we're going to have lots of reasons that we're going to be able to use all in one diagram. So yeah, definitely.
Yes, ma'am. Thank you.
Sure. All right, we're not having a traditional brain break, as I have already said. I told you to take 2 minutes and stretch while I answered questions. I'm now moving on. So if we have a look at question 4, guys, you've already told me in the last lesson that we know that this square over here means that the angle is 90 degrees. Okay, so this is an example of being able to use complementary angles. If we think about setting up our answer here, we have to give a statement, we have to give a reason. But now what we've been given is that we know that these angles have to add up to 90 degrees. And the second we've got adjacent angles adding up to 90 degrees, we have that complementary reason. So we know that x plus 70 must give me 90. And my reason here, quite simply, angles, complementary angles. Again, remember, mathematicians are lazy. If we can abbreviate something, we will. We now solve. This is a nice, easy one. Subtract 70 on both sides. And so we get that x is equal to 20 degrees. And that's all because we knew that this was a complementary angle. It was an angle that added up to 90 degrees. right? So like I said, guys, we don't use this reason often. It really isn't one that we use a lot, but it is one that's very useful to know. Excuse me. And so just knowing that when two adjacent angles add up to 90, we have complementary angles, it's going to be very useful later on down the road, especially when you work with quadrilaterals. All right, with that being said, no, sorry, ignore me for a second. So take a quick screenshot of this one. Like I said, really nothing too tricky here. It's just the fact that we are adding up to 90 degrees. Excuse me. And so we have complementary angles. Wandelia, I'm not too sure what you mean. Complementary in maths means, especially in geometry, means add up to 90. So that's why they're complementary angles. All right, so guys, to finish off, I want to have a look at question 5 because you guys asked me what happens when there's an X and a Y. And this is an example of having X and Y in a question. All right. First thing that you need to notice is that X and Y are at different angles in this diagram. So they're not the same. We also know they're not the same because X and Y are two different variables. They represent different values. What I do want you to notice though, and I'm going to do my best to try and differentiate here, is that if we consider X first, X is on the straight line here in pink, which means that X plus 140 must give me 180. Okay, so if we set up that first bit of our reasoning, we can start with X. Now guys, very importantly, unless the question specifically says you have to answer in alphabetical order, you can start with whatever letter you want, as long as you answer all of the, or you get all of the values that you need to get. It honestly doesn't matter what order you put it in. Okay, my line's skewed, but we're just going to work with it. So remember, statement reason, I'm starting with X, but again, it doesn't matter. The only time it matters is if we specifically tell you to do it in order. And we have made a statement that X plus 140 must give us 180 degrees. Our reason, angles on a straight line. We solve, we subtract 140 on both sides. And so what we get is that X is equal to 40 degrees. Okay, nice and straightforward. Now guys, once I know a piece of information, what I like to do is I like to fill it in on my diagram, just in case it helps me later on in order to get any other angles that I might have. Now there's actually, because I know X, there's actually two ways that we can get Y. I'm going to show you both, but we're just going to pick one when we do our answer. The first way that we can get Y is because I've got 140, I now have X, I have 50, and I'm just looking for Y. I actually have angles around a point here. So I could use that as my reason if I wanted to. The second way I could find Y, the second way that I could find Y is that I could see that very much like X, Y is on the same straight line here. Okay, and so what that means is that 50 plus Y also adds up to 180. Now it makes no difference which reason you choose to go for. Both of them will get you the correct answer. I'm just going to do this one because now it's the last one I have here. We know that Y plus 50 must give me 180. Now guys, this is a new angle that I'm working out, so I have to give my reason. Completely new angle must get its reason. Angles on a straight line. Right, and then we solve for Y by subtracting 50 on both sides. And so Y is equal to 130 degrees. Please make sure you use the correct variable. If you had said X or Z or W or A or whatever, unfortunately, you'll get it wrong. So it must be Y equals. And please remember to give a reason for every new angle that you give. Okay, so again, either you can use angles on a straight line, or because you know 140, X is 40 and 50, You could say that all of those angles together must give you 360 degrees. Those are the two ways you could answer the question. It doesn't matter which way you choose to do it. Both are correct.